All right, let's kick off this explainer with a scenario that, honestly, might hit a little too close to home for some of you. Picture this. It's 3 a.m., you get a page in the middle of the night. Several services running on your Kubernetes cluster have insanely high latency when responding to API requests, your users are experiencing massive slowdowns, and the pressure is completely on. So what do? Do you know exactly where to look and what commands to fire off?
Well, welcome to the Explainer. Today, our mission is to completely demystify managing Kubernetes clusters and resources on Google Cloud. We're cutting through all that noise to focus on the essential commands, configurations, and concepts you actually need to maintain absolute control over your infrastructure. If you've ever felt overwhelmed by the sheer number of moving parts in a cloud environment, trust me, you are in the exact right place.
Here is our roadmap for today. First, we'll master the KH toolset. Then, clusters and nodes explained, followed by managing pods and deployments. And finally, services, images, and autoscaling. Let's get right into it.
Part 1. Master the KH toolset. Okay, before we can even think about solving our 3 a.m. latency crisis, we need to establish the boundaries of our command center. There is a very strict division of labor here, a rule of tool, if you will. When managing a Kubernetes engine environment, you're going to be constantly switching between two main command line tools. On one side, you have gcloud. Use this to manage your broad Google Cloud infrastructure, things like your clusters, nodes, and container images. On the other side is kubectl. Use this to modify the Kubernetes resources living strictly inside that infrastructure, your deployments, your pods, and your services. Maintain this hard line in your head, and you'll never confuse the two.
Now, this might sound crazy, but when using Kubernetes Engine, a cloud engineer really only needs to worry about configuring a specific set of core components. There are exactly 5: nodes, pods, services, clusters, and container images. That's it. If you can master the configuration of those 5 distinct components, you've pretty much mastered the foundational management of this entire environment.
But, what happens when you try to access those components and the system just pushes back? Let's say you fire up your terminal, type in a kubectl command, and boom, you immediately get an error message saying a resource cannot be found, or you just simply can't connect to the cluster. This happens all the time. It usually just means you don't have the proper access privileges configured locally. So the absolute crucial fix here is running gcloud container clusters get credentials. This specific command configures kubectl to use your Google Cloud credentials, instantly eliminating those frustrating connection errors so you can actually get to work.
Moving right along to Part 2, Clusters and Nodes Explained.
Now that our toolset is defined, let's build up our macro management strategy. Navigating the environment quickly is a totally vital skill. Knowing exactly where to find critical cluster and node information is key, whether you prefer the Cloud Console interface or the command line. For instance, if you need to see the details of a specific cluster in the console, simply click the cluster name. Seriously, don't rely on the search bar for this, because that can sometimes bring up instance group details instead. Now, if you're looking at a cluster's details and need to know exactly how many vCPUs are available, you're going to find that specifically in the node pool section of the node's details page. But what if you're acting as a diagnostician and need to understand the high-level characteristics of several clusters at once from your terminal? Easy. You'd run gcloud container clusters list. And finally, let's say a new engineer joins your team and totally forgets to properly label several clusters to meet your team's standards. You can easily modify those labels in the Cloud Console just by clicking the Edit menu option.
Which brings us right back to our 3 a.m. nightmare. You've used your tools, you've checked the cluster details, and you're reviewing the monitoring data. The diagnosis is crystal clear. There are simply not enough resources in the cluster to keep up with the load. You decide the immediate fix is to slap 6 more virtual machines onto the cluster. To actually execute this fix, you're going to use the gcloud container clusters resize command. But you can't just yell add machines at the terminal, right? You got to be specific. You need to provide 3 mandatory parameters: the cluster name, so it knows which environment to target, the node pool name to dictate which resources to expand, and the cluster size, setting exactly how many nodes should be running once the resize is all finished.
Okay, Part 3, Managing Pods and Deployments. So we've stabilized the macro environment. Now let's zoom in on a golden rule of Kubernetes, literally a golden rule. When you want to modify the number of pods in a cluster to handle varying workloads, you might instinctively think you should just add or remove pods. But no! As best practices strictly dictate, modify the deployments. You should not modify pods directly. The deployment acts as your blueprint, configured with a strict specification of the number of replicas that should always be running. You change the blueprint, and Kubernetes handles the pods for you. Simple as that.
If you're a visual person managing this in the Cloud Console, you actually won't find a Deployments menu option. Instead, you'll view a list of your applications and deployments under the Workloads navigation menu. When you drill into a deployment's details and click the Actions menu, you get 4 exact capabilities: Autoscale, Expose, Rolling Update, and Scale. These are your primary levers for controlling how your application behaves and updates within the cluster.
But hey, if you prefer the command line, getting an application off the ground and accessible is a simple 1-2 punch. Step 1. You issue the kubectl run command. This takes a name for the deployment, an image, and a port specification and officially starts the deployment. But at this stage, it's totally isolated. So for step 2, if you want applications outside the cluster to actually have access to those pods, you must issue a kubectl expose deployment command.
And finally, part 4, services, images, and autoscaling.
Let's tie everything together and look at how we respond to real-world dynamic traffic. Imagine you are supporting a team of machine learning engineers. They're testing a series of classifiers in your cluster. Suddenly, they frantically report that one specific service, let's call it ML Classifier 3, is going completely rogue. It's not functioning as expected, and they need it removed from the cluster right this second.
Because this classifier is running as a service, and remembering our rule of tool from earlier, we know that services are managed by Kubernetes, not Google Cloud. Therefore, we definitely don't use gcloud here. We rely on this exact command: Kubernetes delete service ML Classifier 3. The verb comes before the resource type, it targets the Kubernetes API, and it cleanly removes the malfunctioning service. Crisis averted.
Now, as you start pushing out actual models or fully functional applications, you're going to be dealing a lot with container images. There is a vital architectural distinction to keep in mind here. Artifact Registry is the Google Cloud service strictly responsible for managing your container images. Services like Kubernetes Engine and Compute Engine, they just use those images to run the applications, but they do not manage the repository itself. Let's say a data warehouse designer asks you to deploy an extract, transform, and load process. They hand you a strict list of libraries that must be installed, including specific drivers for GPUs. Because images are managed by Google Cloud, you'd first run gcloud container images list to see what you even have available. But to actually verify those GPU drivers are inside, you need to look closer. You'd run gcloud container images describe to get a highly detailed description of a specific container to ensure it actually meets the designer's requirements. Finally, let's tackle the elephant in the room: unpredictable demand. Consider this real-world scenario from the source text. You've deployed an application that processes sensor data from a massive fleet of delivery vehicles. The volume of incoming data is entirely dependent on customer orders. This means your traffic spikes heavily during daytime hours, massive holiday seasons, and whenever major advertising campaigns are running. You need enough nodes to handle the heavy load, but you also really want to keep your costs down during the lulls.
You could just throw budget at it and deploy as many nodes as possible, but let's be real, that's incredibly wasteful. You could write custom scripts or manually sit there monitoring CPU utilization all day, but that is so burdensome and incredibly prone to human error. The absolute best solution is to enable autoscaling. It is the most cost-effective method, it's the least burdensome way to respond to demand changes, and most importantly, it accounts for those unexpected spikes or lulls automatically without you having to manually intervene at all.
Which leaves us with this final thought. We've covered the tools, the macro node management, the micropod deployments, and exactly how to intelligently scale your services. The next time your traffic is violently spiking and your nodes are maxed out in the middle of the night, are your clusters ready to adapt? Take these concepts, apply them to your own Google Cloud environments, and ensure that your infrastructure is just as resilient as the applications running on top of it. Keep exploring, keep learning, and I'll catch you in the next explainer.